Have you ever wondered how businesses keep huge amounts of information organized and easy to find? If that sounds useful, you're in the right place. I'm Kayla with Knack. Let's jump right in. So, what is a relational database exactly? Think of it as a structured system that follows the relational model, where data lives in tables and relationships between tables keep everything connected. Benefits of relational databases include clear organization, built-in data integrity, the ability to scale, and easy sharing across other apps and processes. The core principles are grounded in math. A table is a relation. Each row is a tuple, and each column is an attribute. A primary key uniquely identifies every row so duplicates never sneak through, while foreign keys are the connections between rows in one table to rows in another. Before writing SQL, set clear goals. Decide who will use the database, which data points matter, what actions they'll perform, and how future growth might change things. Strong goals keep your design focused, efficient, and ready for expansion. Now, let's break down relationships. One-to-one pairs a single record with one other record. One-to-many links one record to many in another table through a foreign key. And many-to-many connects several records in one table to several in another and usually needs an extra associative table to manage those links. Design principles keep your database healthy. Normalize your tables to avoid duplicate data. Choose clear names for everything, pick the right data types, and use constraints like primary and foreign keys to lock in integrity. Document your design so anyone can understand it later. Common pitfalls include duplicated data, cryptic names, rigid structures, weak security, and launching without thorough testing. SQL is the language that brings your design to life. Create table lays out columns and constraints. Insert, update, and delete handle data changes. Select pulls out exactly what you need, while foreign key constraints wire tables together for referential integrity. Ready to build? First, define your purpose and data needs. Second, create an optional entity relationship diagram to visualize the links. Third, write SQL to create each table. Specify columns, data types, primary keys, and any foreign keys. Fourth, establish relationships so every order references a valid customer. Fifth, populate the tables with insert statements. Sixth, test queries. Next, you want to identify data requirements. Begin by stating the purpose and identifying who needs the data. List your entities, perhaps customers, products, and orders. Define attributes for each, such as first name, and then map how the entities connect. Involve stakeholders early. Start simple, refine as understanding improves, and document every choice. If writing code is not your passion, Knack's no-code builder does the heavy lifting. Sign in, start a new app, add tables, define fields, and establish relationships with clicks. No SQL required. Relational databases can be really powerful tools if they are maintained properly. To enhance performance of your relational databases, index frequently searched fields to speed lookups, write efficient queries that avoid unnecessary work, and make sure your hardware is optimized. Next, you want to make sure your relational database can be scaled easily. This can be done when you denormalize, archive inactive data, and for very large datasets, consider horizontal scaling that data across servers. Lastly, make sure you plan for the future. Pick a database engine that matches both today's workload and tomorrow's ambitions. Build your schema with room to grow. And finally, monitor performance dashboards so you can spot trouble long before it turns into an emergency. Testing and iteration also keep quality high. Unit tests check individual queries, Integration tests confirm tables work together, and user acceptance tests involve real users to surface usability issues. Measure performance under load, review query plans, and refine accordingly. Choosing the right primary key is foundational. It must be unique, never blank, and as simple as possible. Auto-incrementing integers are popular. Sometimes a natural key like a social security number works if uniqueness is guaranteed and privacy is protected. When one column won't do, combine two or more into a composite key. Even with a strong design, issues can appear later. If redundancy creeps in, revisit normalization. Slow queries may need new indexes or rewritten logic. As data scales, archive historical rows, denormalize selected fields, or shard across servers. Continuous monitoring lets you spot problems early and keeps users happy. Knack's Builder streamlines all of this. Import spreadsheets or CSV files to jumpstart your data. Create tables and fields with a few clicks, and manage records visually. The platform offers forms for data entry, views for dashboards, and secure user roles so you can roll out a polished app quickly. Thanks for spending time with me today. I'm Kayla with Knack. Tap the subscribe button so you never miss our next dive into smart data solutions. Until then, keep building smart and see you soon.